Hello there. This lesson is for geometry and it is titled Linear Measure, and it's chapter 1, section 2 in your textbook, so you can join me because I'm taking some notes here. All right, so linear measure. Unlike a line segment, or you could just call it a segment, so here we got a line segment, or just a segment, can be measured because it has two endpoints. So we can measure a line segment because it actually starts and stops. You can't really measure a line because it goes on forever. So, but you can with a line segment. So what we're going to do today is we're going to talk about how to measure line segments, and also about some notation when you're measuring line segments. For example, for one, first of all, I want to remind you that you can name the segment two different ways. This segment can be called AB. So we can call this segment AB like this, or we can call it BA. They're the same segment. And also, more importantly, I want to let you know that when you, oops, maybe that eraser was a little too big. When you, let's see, there we go, it's a little bit smaller there. Okay, when you are talking about the length of AB, you can actually abbreviate, like instead of saying find the length of AB, I could have abbreviated that by saying find AB using each ruler. That would be the exact same thing, okay? The only difference is that when you say it like this, there's no bar above it, and any geometry person would know that when there's no line above it, they are going to assume that you are talking about the measure of the segment and not the geometric shape of the segment. So that's kind of very important. Like if I ask you to identify a segment, then you have to use the bar above AB. But if I'm asking you to give me the measurement of this segment, then this will suffice. So my answer today could be something like AB equals. Okay, so I want to undo my nonsense there. Bear with me here, sorry, I don't want to keep that scratched out there, but here we go. So my answer today will be AB equals. Okay, that's the first thing I wanted to kind of mention, is that when we write our answers, we're not going to put, if I'm writing the answer of how long something is, the measurement, then I'm not going to use the bar, I'm just going to put AB equals. The second part is that when you are measuring with the ruler, you want to measure. Okay, so I just want to say this right. Okay, here we go. All measurements are approximations dependent upon the smallest unit of measure available. So the smallest unit of measure available on the measuring instrument. So in this case, our measuring instrument is a ruler, and you can see the two differences between the two examples here is that in this case, the smallest unit of measure is centimeters. These are all centimeters, okay? But when you look over here, you can see that there's all these extra little tick marks. So the smallest unit of measure there is different than it is here. So that's why we're doing these examples separately, okay? So here we go with part A. If you look at the example, and this is in your book, you can probably maybe see it a little better in your book, but you can tell that the point B is closer to the 4 than it is to the 3. We don't actually know how much because we don't have little tick marks to measure here in the middle. But we know that it's closer to 4. And since centimeter is the smallest unit of measure on this particular ruler, then I would say that it's basically approximately 4 centimeters. Okay? So that would be my measurement for AB for part A. But now we're going to go to part B. In part B, you probably know or don't know, I don't know. In part B, the smallest unit of measure is actually millimeters. And we know that because if you look at, this is centimeters here, but all these little tick marks in between, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 millimeters in 1 centimeter. So that means that our measurement should be more accurate. It has to be accurate to at least the millimeter mark. So over there, 4 centimeter was the most accurate because we didn't have the little millimeter markers. But in this case, we do. So we're going to go 1, 2, 3, then we're going to count these little suckers. 1, 2, 3, 4, 5, 6, 7. Looks like it's 3 3.7 millimeters. Okay, so again, over there, because the smallest unit of measure on our measuring instrument was centimeters, then our answer was in centimeters. But because in this case, the smallest unit of measure is millimeters, then we're going to answer in millimeters, and we're going to get more accurate, and so AB equals 3.7 millimeters. All right, so now we're going to ask you to try some things. A and B, you want to use your own ruler and do that. We are using items that are typically uniform in length for everybody. Most pencils come in the same size, most dollar bills come in the same size, so hopefully people won't get measurements that are way off for A and B. And then in part C, you're actually going to be using this makeshift ruler here to calculate that. Now again, if you want, this is in your textbook. I think it's on page 14. So if you don't like the way this diagram looks, I try to make it as accurate as possible, then you can use the one in your book. All right. So here we go. Now we're doing the exact same thing, only this time we're going to be using standard units. So last time we were using the metric system, centimeters, millimeters. Now we're going to be using the silly system, which is the standard system, which is inches and all that kind of thing. But again, same idea holds. Whatever your smallest unit of measure is, that's what you want to use. So you can see that here we have fourths. I know you guys don't like fractions, but we have 0. Here's 1 inch, and the 1 inch is divided into 1, 2, 3, 4 pieces. So we're going to go to the nearest 1/4 inch. Okay, so it looks like this is 1 1/4 inches. So we're going to say that CD is 1 1/4 inches. All right. And then we're going to go to the other ruler and we're going to try to get more accurate. So again, when you have these little markings in here, you could count them if you want to. We'll do that now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So basically the standard system, you basically keep halving everything. Like you have an inch, and then you look, you half that, you get half an inch, then you half the half and you get a 1/4 inch, then you half the half and you get an eighth, and then you half the half and you get a 16th. So what you have right here is 16ths. The smallest unit of measure is 16 because a 16th. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 little markings before you get to the 1. So we're going to measure to the nearest 16th. Okay? So here's 1 inch. That one's easy. So that's going to be 1 inch. And then you have 1, 2, 3, 4. So 1 4/16 inches. But we also want to, even though this is like the most accurate measure, at this point now we can try to reduce. If this had said 1 3/16, so we would leave it alone. But we know that 4 and 16 have 4 in common, so we can reduce our fraction. And again, end up with 1 1/4 inches. So in this case, we get the same answer for both measurements, A and B. But that won't always be the case. So now we're going to go here, and you're basically doing the exact same thing you did in the first example, only now you're going to be measuring in inches. So in the first example, the first do-it-yourself, you were measuring in, I think, centimeters and millimeters. And now you're going to measure the dollar bill and the pencil again, but this time using inches. All right, so then we move on to what is probably the nicer part of the section, the part that I like the most anyway. And we're talking about betweenness of points, okay? That's kind of a weird word, betweenness, but let's kind of go with the definition here. Point M, okay, so here's a point M. Point M is between, okay, that's the key word there. Point M is said to be between points P and Q, which obviously you can see the diagram, but there are a couple of conditions for this to happen, there are 2 conditions actually, for this to actually be the case. Now I obviously drew a diagram that works, but there are diagrams that don't work, and so just want to make sure that you understand what the 2 things are. Okay? Point M is considered to be between P and Q if and only if. Okay? And sometimes we abbreviate the if and only if with this funky double F, if. Okay? If and only if. I didn't do that the first time around because I didn't want you guys to get confused. But in the future, if you see that double F, if, it means if and only if. So, what are the if and only ifs? There's 2 of them. First one is that P, Q, and M, so points P, Q, and M have to be collinear. That's number 1. They have to be collinear. Which, of course, you can see in my diagram on the blue line, they are, in fact, collinear. Also, the second part is that PM, notice how there's no bar on the PM. So this is saying the length of PM from here to here. Okay, so you can see the black part there. PM plus MQ equals PQ. Now that seems really strange, and again, these are all, there's no bars above any of them. That all means length of. So what it is saying is that the only way that we know that M is in the middle is if they're collinear, and secondly, if you take the two pieces and when you put them together, they equal the whole. Okay? If I take PM by itself and MQ by itself and add them together, they should equal the whole. Okay? So pretty important definition there. So we're going to use that we're going to apply that to our examples here. We have, I think, 3 examples that I want to show you. This first example is going to show you how to use that property, the betweenness, using addition. Then we'll do subtraction, and then we'll do some algebra. So they want us to find, notice how they got rid of all the language, the measure of. It just says find EG. So because it doesn't have a bar on it, we know that they want us to find the length of EG. So, really basic one here, EG. To find the length of EG, I have to go, because they're collinear, I know that the distance from E to F plus the distance from F to G will equal the whole distance. So I know from the diagram that EF is 2 3/4 inches. And I know that FG is also 2 3/4 inches. Even if it doesn't look that way on the diagram, it says that we can assume the figure is not on the scale, but it tells us that it's 2 3/4 inches. So that means that we can add our 2's together and get 4, and then add our 3/4 and 3/4 is 6/4. Okay, but 6/4 is an improper number because 4 goes into 6 at least once, with the remainder of 2. So this is actually 4 plus the mixed number here, 1 2/4. So that's 5 1/2. The 4 and the 1 become 5. The 2/4 gets reduced to 1/2. So there's my answer. 5 1/2 inches for EG. So basically I can add the 2 parts and it equals the whole, which is what we were just talking about in the last definition. All right, so now you can try this one on your own. Again, using addition to find the distance of JL, the length of JL. And then you can use subtraction. You can also use subtraction to find distances or measures of segments. So like in this case, we, for example, know that AC, which is the entire distance, is equal to AB plus BC. But in this case, they want us to find AB, not AC, like in the last case. So I can subtract BC from both sides, and I can get that AB is equal to AC minus BC. And we know that AC is 13.2, and we know that BC is 5.8. So, using subtraction this time instead of addition, we can get that AB is 7.4, and that was meters. All right? So this time the do-it-yourself problem is on the same screen, so you can see it down there again, using subtraction to find the measure of a segment. Okay? So then we have our last example, which I think is the most interesting. And it's find the value of A and xy if y is between x and z, xy equals 3a, x equals 5 minus 4, and y equals 14. And if we, by now looking at that, you're going, what in the world did she just say? Remember that in order for all this to work, it has to be collinear. So one of the first things we're going to do, and you should as well, is even though it doesn't say, we should draw our diagram. So we're going to draw a diagram, okay? And it says that they want us to find xy, but it says that y is between x and z. So what we want to do is somewhere on our line, we want to put x, we want to put z, and then y has to be in between. Now remember, this is not necessarily drawn to scale because we don't know what the individual measurements are yet. But as long as y is in between x and z, they're collinear, then we can proceed. So that's the first part, is that y is between x and z. the next part says that xy equals 3a. So that means that this piece right here is 3a. xz, which is, so that's going to be this guy. That's xy. Okay, but x to z is 5a minus 4. Okay, the entire thing is 5a minus 4. And then yz is equal to 14. 14, okay? Now again, we know from the between this earlier that xy plus yz, in other words, the two pieces should equal the whole. If we do it like that, then we can just substitute what we know from the diagram. xy we know is 3a. yz we know is 14. xz we know is 5a minus 4. And from here, we just proceed to solve it algebraically. So we're going to subtract the 3a from both sides, add the 4 to both sides, doing two steps at once. 3a minus 3 is 0, 14 plus 4 is 18, and then 5 minus 3 is 2, and negative 4 plus 4 is 0. Our last step is to divide by 2, and a equals 9, because 18 divided by 2 is 9. So that was the first part, find the value of a equals 9. But that isn't the only part. It said, it also wants us to find xy, right here. So xy, you'll remember, is 3a. So xy equals 3a, which equals 3 times 9, which equals 27. So a equals 9 and xy equals 27. And that's how we can use algebra to also find values of variables and to find lengths of segments. Okay? So this is your last do-it-yourself example. Once you have completed this example, you have completed your notes for today, and I will see you in class. Thanks for watching.